All right, hello out there in remote land. We are jumping into a new topic, very exciting, talking about minerals. A lot of people love this topic, right? The gems of the earth. Everybody sees these beautiful stones and get all excited. So really cool. We're going to learn all about that, how they form, what makes one different from the other, how they relate to rocks. So kind of a fun unit, right? A lot of it's called geology. So here we go. What are minerals and how do we describe them? Well, we use them all the time. We don't even think about it. But all the products that we use are all full of these earth minerals, and we've manipulated them, right, in our manufacturing processes to make useful things for us. All right. Well, it all starts out, of course, at the mine, right, where you get it out from the earth. Now, this truck, this one's going back at least 10 years at this point. They're even bigger at this point. But if you look at this truck, it's absolutely enormous, right? That's the person standing there. To get on this truck, you got to climb the ladder all the way up to get into the cab. And these things are truly amazing. They're built in the factory, then they have to be shipped in parts, and then they have to be assembled at the mine because the roads aren't big enough for this truck. Bridges aren't high enough for it to go under. So it kind of gets assembled at the mine and lives out its life there. And, you know, it's... You say, well, what the heck do you need something that big for? Well, if you want to make it in the mining industry, you have to move a lot of earth material. And that's exactly what this does. So please read this article. It's quite interesting with the stats underneath here. It's called the Caterpillar 797 with 3,400 horsepower. Pretty impressive. These are the tires on that truck. Each tire costs about as much as a car roughly nowadays, right? $25,000 per tire. Truck needs 6 of them. These were about 12 foot 6 inches tall, but like I said, they've gotten even bigger. That was my son, my older son anyway, 10 years back. And you could see how enormous this tire is. Well, there are 6 of those on this truck. So now you can imagine how big the truck is and how big the crane is that's filling it. And mines have several of, these pieces of machinery. So when you look at the mine, what's it digging out? This used to be a mountain that was removed, and they got the minerals out of it, and then they kept getting a lot of minerals, so they kept digging. And this hole is actually visible from an orbiting spacecraft. That's how deep this hole is. It's called the Bingham Canyon Mine out in Utah. And you can see little black specks down there. Those are those monster trucks doing their thing, digging. This is called, again, the Bingham Canyon Mine out in Utah. And the biggest thing they get out of there, the most mineral they get, is copper. And you might say, copper? Copper isn't expensive. No, but it's in almost everything we use in daily life, right? Wiring, plumbing, some of our coins. And it makes it safe, right? Copper pipes are much safer to drink out of than the old lead pipes. Copper wiring is much safer. They switched over to aluminum wiring because it was cheaper during the war. And houses started burning down because aluminum is not as good a conductor as copper. So a lot of benefits and a high demand, as you can imagine. Now here's that pit. Once they get the material out of there, it's dumped onto a conveyor belt, which goes for many miles. And it gets processed and crushed and smelted into its pure form. Pretty amazing. Okay, so here we have it. How do we define minerals? Well, what makes a mineral a mineral? First off, it's got to be naturally occurring, right? It can't be synthetic, can't be human-made. It's got to form naturally in nature. Second is it's got to be solid. If you melt it, it's no longer a mineral. Inorganic, not from a living thing. Okay, and it needs a definite chemical composition and a specific arrangement of atoms. Well, what's an atom? Well, atoms I'm sure you've heard of, right? The parts of an atom anyway, the subatomic particles, protons, neutrons, electrons, right? It's the smallest unit of any chemical element, and it's the building block that makes up everything here on Earth, right? They're too small to see with the naked eye, but they are the building blocks. Okay, so make sure you get your notes down there. Okay. How is one mineral different from another? Well, what makes this copper? What makes this gold? What makes this sulfur? Or is that gold, right? You've heard of fool's gold. They call that pyrite. The difference, of course, is, well, for one, the elements that they're made up of. Okay, this is pure copper, this is pure sulfur. If this is real gold, then it's pure gold. But when you combine these elements in different ratios, you make different minerals. Okay? For example, quartz you've all heard of. Well, that's the combination of silicon and oxygen. It's called a silicate. Same thing with potassium feldspar. You can see the silicon and oxygen there. It's also a silicate, but clearly those are different minerals. Okay? So you combine different elements, you get different minerals. You arrange the atoms differently, you get different properties about those minerals. Pretty cool stuff. Okay? Makeup companies use minerals, right? But they all use pretty similar minerals. Makeup tends to be shiny. Well, then you have to have a soft, so it doesn't scratch the skin, but shiny mineral, and mica is one of the big ones that makeup companies will use. And here it is, that's mica. It'll peel in sheets, and you can see how reflective it is of the light. And that's mixed in very, very, very fine powder, of course, with many cosmetic products. So the two most abundant elements in the Earth's crust, if you look at your chart, this is on the reference tables, front page, and you can see right off the bat, element, oxygen and silicon by mass are definitely more than anything else. And oxygen by volume is way more than anything else. Right? The second one by volume, of course, would be, looks like potassium there, right? The second highest number. But silicon and oxygen are the big two by mass, and as a result, they make up most of the materials on Earth. Because let's face it, if you're going to bake something and you go to your cupboard and you have your fridge in your cupboard and you have flour, eggs, sugar, well, then most of what you're baking is going to have flours, eggs, and sugar because those are the ingredients you have, right? You can't use what you don't have. Same thing with Mother Nature here. The two most common ingredients are silicon and oxygen, so most of the minerals are made from those two elements. Okay? 90%, in fact, of minerals in the Earth's crust are made of silicon and oxygen. Again, they're called silicates. Okay? How do they form naturally? Well, two big ways. You have elements or minerals dissolved in water. When the water evaporates, the mineral precipitates and crystallizes. Or from a volcano, right? When lava cools, lava is made of different elements. And as that lava cools, the minerals start to grow and crystallize. All right, those are the two big ways that Mother Nature makes minerals for us. Here you can see an evaporation process. And here you can see, of course, lava, right? An igneous process. Okay. What structure forms? Well, this is a very common form. It's a silicon, oxygen, what we call tetrahedron. Kind of looks like a pyramid if you look. If you connected all those sides, it would look like a pyramid. And that is a very, very common structure in silicates because, once again, it includes the silicon and the oxygen. Okay? These are different ways they draw it, but it's all the same thing, right? It's just different perspective there of that pyramid-shaped molecule. All right, the silicon-oxygen tetrahedron. So now how do we arrange these atoms? Well, if you arrange them differently, you make different properties of the mineral. For example, if you arrange them in a nice tight network, you'll get something that's very solid, very strong, hard to break. And quartz is a very tough mineral. It will shatter if you hit it hard enough, but it's extremely hard. It'll scratch glass. It doesn't break very easily. And that's because of its arrangement of atoms. Unlike if you arrange them in these chains or sheets, well, then the mineral breaks easily, like mica with that makeup we were talking about. Mica is very soft. It breaks easily, and it's arranged in sheets. The mineral in your pencil, the same thing, right? Graphite is what does what's called cleaves in sheets, right? It'll break in these sheets. And as you write on the paper, it's cleaving that mineral on the paper. That's why it writes. And the harder you press, the more you cleave off or break off, and the darker the writing gets. Well, interestingly enough, both graphite and diamond are made from the same material. Right? That material being carbon. But when you arrange the atoms differently, you get something that's worth 10 cents, or you get something that's worth thousands and thousands of dollars. And that's all just by changing the arrangement of these atoms. Okay? Everybody always asks, well, can I turn my pencil into a diamond? Not quite, right? You'd have to isolate all the graphite, melt it down into lava, and then pressurize the heck out of it and let it cool. And then maybe it'll crystallize into a diamond. But the material to do that, of course, is extremely expensive. So, maybe you're better off just finding one in nature. All right, carbon atoms are bonded tighter in diamonds than in graphite, and of course end up making a completely different mineral out of the same ingredient. Why are minerals not rocks, right? They're solid, they look like rocks. Well, rocks are often composed of many different minerals. We call them polymineralic. So you can't just say, oh, it's a mineral. No, it's got a bunch of different minerals in there. This is granite. I'm sure you've heard of it, seen it at countertops. Maybe you've seen it at Home Depot, outside, wherever. It's made of at least 5 different minerals usually. All right. This, you can't tell what is it as a mineral rock. Some rocks have almost all one mineral. They're called monomineralic, but they still have impurities. If there are no impurities and it's just made of one mineral, well, then it's just a pure mineral. But that's not the case. If it's a rock, it's not a pure sample. Okay? And there you have it. Rocks are often made up of one or more minerals. Okay, so what you guys got to do, you got to run through and put some different examples here. You have to decide whether it's a mineral or not, or which one is the mineral, and circle the mineral, and then, of course, explain why it is a mineral, why not. I'll give you one example here. Which sample is a mineral? Well, we have diamonds on the left, cubic zirconium on the right. Take a second, think about it. Well, we just discussed diamonds being a mineral. So run through the questions. Are they solid? Yes. Are they naturally occurring? Yes. Well, they're both solid, but these are synthetic, right? They're made in a lab, so they're not naturally occurring. And of course, that's why you got to circle the diamond, because it's a solid, inorganic, natural material, whereas the cubic zirconium is not. All right? So run through. I put a bunch of examples there, and make sure you explain it. And of course, there's a couple summary questions that follow. All right? I'll meet you back in the meet to chat what you got.